Day 2 of verifying trigonometric identities. We're just going to look at a couple more examples in this video. Once again, establishing the identity. Secant of theta minus tangent of theta is equal to cosine of theta divided by 1 plus sine of theta. So once again, we want to start with the more complicated side, and either one of these would be okay choices. You have secant and tangent, which you can change to sine and cosine. The right-hand side, you got cosine of theta divided by 1 plus sine of theta. There's a couple options there we could kind of mess with, but let's go ahead and work with the left-hand side here, since we can change those to cosine and sine. So we will take the secant of theta and rewrite it as the reciprocal, which is 1 over cosine of theta, minus tangent of theta, we can rewrite as sine of theta over cosine of theta. We notice that we have a cosine of theta on top and a 1 plus sine of theta on bottom. We do have a common denominator, so we will combine the numerators. So if you look at, we have something similar to the right-hand side, but definitely not the same. So what can we do? Well, sometimes we can actually force the issue. What I mean by that is we need a cosine of theta on top. So what we can do is multiply by cosine of theta to the numerator and the denominator. So that forces the cosine of theta in the numerator, and now in the denominator we get cosine squared of theta. So we now have the cosine of theta on top, but we can also rewrite cosine squared of theta using the Pythagorean identity as 1 minus sine squared of theta. Well, if you notice, that is a difference of squares. So we can rewrite that as 1 minus sine of theta times 1 plus sine of theta. And remember, don't forget what we're trying to accomplish. We have the cosine of theta on top. We're trying to get that 1 plus sine of theta on bottom. So you'll notice that now the 1 minus sine of theta does cancel. And so now all you're left with in the numerator is cosine of theta. And then in the denominator, 1 plus sine of theta, which was exactly what we were trying to get. So we have established or proven that secant of theta minus tangent of theta is equal to cosine of theta divided by 1 plus sine of theta. Alright, on example 2 here, we have 1 plus tangent of theta divided by 1 minus tangent of theta is equal to cotangent of theta plus 1 divided by cotangent of theta minus 1. Tangent and cotangent are reciprocal, so once again you can kind of do either side here. I'd rather change the cotangent to tangent, so I'm going to start with the right-hand side and rewrite this as 1 divided by tangent of theta plus 1 all over 1 divided by tangent of theta minus 1. So we could look at this and decide that we could find a common denominator, which that is potentially a way to go here. The other thing that we could do is multiply this entire numerator to get rid of tangent of theta on the bottom. That way we don't have a complex fraction. And then same thing with the denominator, is multiplied by the tangent of theta. So I'm going to distribute tangent of theta to the numerator, and that will cancel out this one. So you'll be left with 1 plus, and then it's 1 times tangent of theta there, so that's 1 plus tangent of theta. So that eliminates that complex fraction. And then on the bottom, you would multiply tangent of theta to the first term, so that would cancel and leave you with 1 minus, and then tangent of theta times negative 1 would be minus tangent of theta. And we did that really just to simplify and get rid of the complex number, and in doing so we actually established the identity, and we're able to prove that 1 plus tangent of theta divided by 1 minus tangent of theta is equal to cotangent of theta plus 1 divided by cotangent of theta minus 1. And the last example we're going to look at in this video is 1 minus sine of theta over 1 plus sine of theta is equal to secant of theta minus tangent of theta quantity squared. So I'd say definitely the right-hand side on this one is the one we want to start with. It's definitely more complex. We could go ahead and multiply secant of theta minus tangent of theta times itself. But also remember, secant of theta can be rewritten using the reciprocal. So we'll do 1 minus cosine of theta. Maybe we can simplify this before we actually square it. And then we'll get sine of theta divided by cosine of theta for tangent. And so before we square it, we'll combine our two fractions since they do have a common denominator. And that way we create one term instead of a binomial squared. So if we square the top, we'll have 1 minus sine of theta. That whole quantity is squared. And then on bottom we have cosine squared of theta. And so remember, what we're trying to get to is 1 minus sine of theta in the numerator. And we have one of those in there, but we have an extra one. And then on bottom we have 1 plus sine of theta. So let's leave the numerator the way it is, because we already have 1 minus sine of theta in there. We just have an extra one that hopefully is going to cancel out. Cosine squared can be rewritten as 1 minus sine squared using the Pythagorean identity. And we will then be able to simplify or actually factor the denominator, because it is a difference of squares. So that'll be 1 minus sine of theta. So you can see one of those is going to cancel out. And then 1 plus sine of theta. So these will cancel, and you'll be left with 1 minus sine of theta divided by 1 plus sine of theta. And so therefore, once again, we have established or proved that the original 1 minus sine of theta divided by 1 plus sine of theta is equivalent to the quantity secant of theta minus tangent of theta squared. And so once again, take a little bit of time to write the summary of what we just saw in this video. Also remember some of those key things in terms of starting with the most complicated side. Also rewriting things as sine and cosine is beneficial when you have kind of no other options there. And also remember, you can only manipulate one side at a time. You can't change both sides. When you're establishing and proving identity, you can only manipulate one side at a time.